Today we are going to see VPC flow logs. So long we were been seeing how to create a VPC, how to connect to a private instance in a VPC, how to connect your VPC to on-premise infrastructure, and how to connect it to another VPC in the same region. So all those things are working fine. It is great. But what if for some reason you are not able to send traffic to a particular instance or a particular resource? Or what if something goes wrong? There is a performance impact, or there is a lot of requests coming and failing. How do you troubleshoot it? How do I find the logs for my VPC? So that is where the feature of AWS VPC flow logs comes into picture. It gives you a nice mechanism to capture those logs and analyze them also using the rudimentary tools. If you want a really rich dashboard and a lot of analytics tools, then you can take these logs and feed into a ELK stack or a Splunk kind of a third-party tool to create your dashboards and look into them. So today we are going to see what is VPC flow logs, how we can set it up, and what are the different elements that are getting captured, how granular you can capture the logs, and also how to analyze them when you're looking at into the dashboard. So when you're talking about VPC flow logs, the most interesting thing and the most startling thing I would say is it is agentless. What it means is if you have an EC2 resource running inside an VPC and you want to track all the packets going in and out of the EC2 instance or a particular interface in an EC2 instance, you don't have to install any agent in the EC2 instance. You don't have to install and configure an agent in the VPC level, because you can capture logs at an interface level, or you can capture logs at an VPC level, or you can capture logs at a subnet level also. So there are multiple ways you can capture or multiple levels of granularity you can capture your VPC flow logs. So it is not just about a granularity level. The VPC flow logs have been integrated with the AWS CloudWatch mechanism or the monitoring mechanism that Amazon provides. So you can take all these logs and create a log data, and you can have rudimentary searches based on IP address or whether the packets have been accepted or rejected or what date they have been created. And you can create an alarm for those metrics also. Say, for example, somebody accessing it from a particular IP address, which they shouldn't be, then you can trigger an alarm. Or if there is a lot of packets getting rejected for a particular IP address, then you can configure CloudWatch to pick up that failure and trigger an alarm. Or you can, again, as I said earlier, you can feed it into a third-party system and have a more sophisticated analysis running on that. People quite often use web server logs and try to understand what is the kind of traffic they are getting, what time they are getting, and from what region they are getting. So you can do all those kind of analysis. You can think of VPC flow logs analogous to TCP dump that gets done in Unix world, or Wireshark, that is the older tool name, I believe, that was used to collect data from the packet level and inspect them at the packet level. So it is not as sophisticated as Wireshark does, but it gives you a very nice high-level view of what packet is accepted, what is rejected, what is the source, and all those kind of things. And it also sees the security groups also. Say you have allowed port 80, and then you can go and see whether the port 80 traffic is starting to flow or not. So in such a way that you can analyze your traffic and troubleshoot your network connectivity also, in case your on-premise is not connecting, or between two VPCs there are no traffic flowing through. So it is simple and straightforward to set it up. So as I show here a couple of screenshots, whenever you click on the VPC or select a VPC for which you want to create a flow log, in the bottom panel of the screen you will have summary, flow logs, and tags. Remember earlier when we were looking at the panel, we said that we look up to it later. So we are going to see that now. All you have to do is click on the flow logs, and when you're doing it through a GUI, it will pop up a window which will ask you some information saying where you want to store the logs, what is the IAM roles that you need to use for the logs, and other things. There are a lot of flow. The flow for creating this will come in a GUI, and everything that can be done on the single screen itself if you're doing it through a GUI. If you're doing it through a CLI, you need to take some precedence. That is, you need to set up the IAM role before itself. You need to set up the S3 bucket where the logs can be stored, and also the CloudWatch metrics also. So, but when you're doing it a GUI, you can go back and forth because you can just click the back button and go front and back. So it is easy to do it in the console itself. So assuming that you have done it now, you have created a flow logs for your VPC and you are having some traffic flowing in and out of your website or your web server. So when you come to CloudWatch, this is how it will look like. On the top of your screen is the flow logs for the timestamps are also there. And you can see here there are multiple details listed out. Let us go ahead a little bit one by one to find out. That is not working. So let us go one by one and find out what each and every information here is. So I'm just trying to get my clicker working. Okay. Okay, yeah, there we go. So the first one is the AWS account, from where which account the interface is configured. The second information that comes up in a particular log, let us say we have opened one particular log. This is how the log will look like. And the second one is your interface, which ENI or network interface the log has originated. And then the source and destination, source IP, source port, and the destination IP and destination port, and which protocol they are connecting, whether it is port 80, port 53, ICMP, UDP, all those kind of things, and how many packets were sent, and what is the size of those packets, and what time it started the traffic, and what time the traffic ended, and finally whether the traffic was actually accepted or rejected, and whether everything is okay or not. So these are the different parameters when you look at the flow logs. Typically, people look at search for IP address and see what happens to the source IP address and whether the packets are accepted or rejected, and see the protocol and the port number. So that is the easiest way to troubleshoot within the VPC flow logs itself. But if you want to run multiple analysis and algorithms to find out whether a lot of reject is happening for a particular interface, then you will need some third-party mechanism for that. VPC flow logs gives you rudimentary checks, but always remember that it is not going to be enough if you want to do in-depth analysis of the logs itself. You can create the logs, but analysis will have to happen outside. So this is what we are going to do as a quick demo. What we are going to do is we are going to set up a sample VPC quickly through an automated script. And then once we set up the VPC, we are going to start a web server inside that VPC in the public subnet, and we are all going to access it. So we are going to generate some logs. Before the accessing part, we go to the VPC and create the flow logs, the log group that is necessary, or in other words, the S3 bucket, and also the CloudWatch log group, and then the IAM role also from the dashboard itself. Then we can go ahead and click on it, and usually it takes about 5-10 minutes or 15 minutes for the logs to appear on the dashboard itself, because Amazon has to collect all the logs and process it and then store it into the S3 bucket. So it takes about 10-15 minutes. So meanwhile, we can go to another topic quickly and come back here and see the logs after some time. So to begin with, let us start with creating our VPC quickly. So what we are going to do is we are going to use a script so that we can quickly go ahead and set up our VPC. Just like yesterday, I'm going to use the same script that we did. I'm just going to modify it slightly, saying let us say today we are using 246, and I'm going to name the tag name to VPC flow logs, so that we know that this VPC has been created for flow logs. So I'm just going to copy this into my Linux server. I'm going to cd/temp. That shouldn't work because it is .vpc. Okay, 246. Is there an error? There is an error. Okay, I'm just going to clean it up. That is one problem if you're having a script and which is creating error. I'm just going to check whether my VPC has been initiated or not. Just let me go ahead and clean it up. I just updated my CIDR range so that it was also 246 everywhere. So it should work now properly, and it should get completed in a minute or so. So let us go to our dashboard and just refresh our screen. We see here we got a new VPC flow logs VPC, and underneath that we are having a 10.246 series, and this should give us about 512 IP addresses totally. And I have created 6 subnets, just like yesterday that we did. And you can see here it is spread across 2 availability zones. Let me just put AZ1, and you can see here public, private, and spare, and each of them will have about 256 IP addresses put together totally. So that is how you split an VPC. Totally, the VPC itself was 512, and each AZ has 256. And within each AZ, I have given maximum for private, that is 128, and then spare is having about 64, and public is having another 64. And remember, 5 of them will be absorbed by AWS itself for their internal use cases. So now we have set up our VPC. Let us go ahead and start our public instance. Let us have our quick web server running so that we can generate some logs as well. So let us have flow logs, AZ1 public subnet, good. And let us have a public IP address, and I'm going to use an EC2 to S3 role here, and I'm going to copy some files from my S3 bucket. So now we have done that. So let us go ahead and click on next to add storage. We don't need any storage, just go ahead and add tags. So VPC flow logs demo server. So configure security group, I'm going to put it in a public security group so that we will have port 80 access. So this is my public security group, as you can see here, and it has port 80, port 43, port 22 access. So review and launch. I don't need SSH keys, but I can just go ahead and add it also. I'm not going to troubleshoot anything here. So now let my web server come up online. So now what we are going to do is we are going to create a VPC flow log for my VPC. So how do I do that? The first step is go to the VPC, ensure that the VPC for which you want to create a flow log is selected. And below that, you will have this 3 tabs, CIDR blogs, summary, and flow logs. Click on this one. And by default, nothing is configured. So the first thing you need to do is click on create flow logs. So when you do this, now we are going to monitor all the traffic that is happening on the VPC level. But if you want to do it at a subnet level or an interface level, all you have to do is, I'm just going to show it to you under subnets. And remember, our server is running on AZ1 public. So I'm going to select AZ1 public here. And then here also, I will have flow logs. So if I come here and create it, my flow logs is going to capture only at a subnet level. If I want an internet level, interface level, that also is possible. What I have to do is, all I have to go to my EC2, and then here you will have Elastic Network Interfaces. And here I can come and select my interface. And here you have flow logs here. And if I click on this option now, it is going to collect all the traffic only for this interface now. So that is how you create the granularity, because at a VPC you will have hundreds of interfaces. You don't want all the traffic. If you want to troubleshoot it for a particular one, then you want to come to an interface level and you want to do it. Or if you want to see a subnet is misfunctioning or malfunctioning or having some issues, you want to do it at a subnet level. Or no traffic is happening in your VPC, then you come to your VPC level and create your flow logs. But wherever you do that, the process is going to be almost the same. It is just that the amount of data you are going to collect is going to vary now. So there is going to click on that, and then it is asking you what you want to do, whether you want to capture all traffic or you want to capture only accept and reject traffic. So let us put all of them. And it is asking me role here, and I'm just clicking on it, and it is going to list me all the roles that I have, whether any matching role is there. So let us say I don't have any roles. All you have to do is click on the setup permissions. It will automatically go to another tab which will pre-configure it with the permissions and all those things. So let it finish the spinning of the permissions and pre-populate all the fields. We just go ahead and click on create a role. So there you go. You see here there is a flow logs role automatically created, and if we click on the policy document, it has created the necessary policy. That is, this is an IAM policy written in JSON format, and it has pre-populated most of the fields. And all I'm going to do is click on allow now. So now my role is getting created, and it will take me to the VPC dashboard. So now that we have created our IAM role, and if I click on this and then it will spin and find out, see here there is a flow logs role created. I'm going to select that, and it is automatically filled up with the ARN role for the IAM role, and it is asking me what is my destination log group, where do I want to store it. If you click on this eye icon, which is going to be a friendly notice message on what needs to be there, you will give you a better idea. In other words, where do I want to store it? So if I click on that, it is asking me, do I have a log group name already created? So it appears that I already have a Valaxy log group name, but in case if you don't have it, what you need to do is, let us go to our CloudWatch. So we are going to slightly touch upon CloudWatch now. So once again, go to the service and search for CloudWatch. On the left hand side, you will usually find log groups or logs, as you can see here. Click on logs, and then you can create go to actions and click on create a log group. So I'm just going to say VPC flow logs demo by Valaxy, just naming the different ways, so that I'm just going to copy it so we can use it when you go back to our VPC dashboard. So you see here there are two. I can go ahead and delete this one. This was created earlier. I can delete this one also, but let it be there because there might be some logs. In case our logs are not flowing, we can go ahead and check this one. But this is the one we have created just now, VPC flow logs demo by Valaxy. So we'll go back to our VPC dashboard and click on this button again. It will refresh it and show our logs as well. So just go ahead and click on this one and click on create flow logs. That's it. We have set up our flow logs and it will start monitoring, and you can see here the status is active. It is going to monitor all the traffic that is happening in my VPC. So the only step that we are left with to do is go to our web server and start and see whether our web server is active, and we can go ahead and browse it. So we should be able to find the IP address here. Let me copy it. Let me put it into the browser. And I'm going to share it with all of you so that you can generate some traffic. I'll probably click it multiple times, so we'll have multiple IP addresses hitting our web server. So you can see here the web server is running, and I made the initial request. So my IP address, my source and destination, and the port 80 that we are calling through, and the amount of traffic that was sent, all those are getting captured off the background. So it should start showing in your CloudWatch log groups anytime. So what you have to do is you come to the CloudWatch dashboard, and all you have to do is just click on this one, and after some time it will start showing up on your stream, as it is called as. So let me just go ahead and see if any of the old ones are still having some data. So if I just click on, this is the old log group, by the way, and I'm just clicked on the old one, and you can see here the date is somewhere August 11th, I think. So if I click on this one, I don't know whether data is there or not, but it will show it interface level, and you can see here the data, each and every packet that has been captured is shown here. You can expand it to see a more, if there are multiple detail information, that will come up and show here. So this is the account, and this is the interface, and this is the source IP address, and this is the destination, and port, and then packet size, and timestamps. So, and this traffic was accepted. Say for example, I want to filter all the traffic by this guy. So there are certain level of filtering you can do. I have not tried many. I usually try to filter it based on IP address, and it tries to filter the logs based on that. Maybe we can try a reject log also to see whether only reject functionality is there. No, it didn't work. That is what, as I said, it gives you a rudimentary feeling of the search functionality here. If you want more advanced, then you will probably have to feed it into another system, and then filter it with those tools, advanced tools that you get. Maybe let me try reject is there. Let me just try reject. I'm not sure whether this will work, but let me try it. Yeah, that worked when I just moved it to text and all the reject packets are showing up. Let me just go ahead and say I want reject only for this IP address. Yep, that also works. So just go ahead and try different things, whether you want to filter it based on a particular IP address or a particular, I don't think so you can specify with the tags saying port equal to 53 or something like that. Go ahead and try it and let me know whether it works or not. So you can see here our logs have rolled. This is the interface for our web server. To ensure that this is our interface, what I'm going to do is I'm just going to copy this text and go to my EC2 dashboard. And if I do Control F and put it there, you can see here my interface is shining and bright. It's the same interface that we are collecting data from, and it is all showing in text format. And let us see, it is all in port 80, or already I'm getting some pings from very high port. Somebody is trying to scan me. You see here there is some very high port scan that is happening, and that request is getting rejected. So most of the port 80 should be rejected. I'm not sure what is this. Okay, so the internal port and then the external port. Yeah, this is my internal IP address, this is my external IP address. So good. So you can see here all this traffic is flowing through. So go ahead and set up your VPC and go ahead and experiment and play around with it to find out what is happening. Let me just put capital reject and see what is happening. So you see here all the high ports with the 774, 445. There are always, when you open a server, web server in the internet, there is always malicious users trying to take advantage of it. You can see here all the high ports are trying to scan my server and trying to see if there is any way to get into it. So there is a port 8080 request is also there coming from somebody. So very interesting, a lot of people scanning. But anyway, my security group is allowing only port 80 and 443 only, so most of them are getting rejected. Now we are going to see another interesting feature provided by Amazon, that is elastic load balancers. This service allows you a lot of functionality, a lot of features are there. Basically, it does the same as just as the name says. It is going to allow you to balance the load between multiple servers spread across multiple availability zones. But the limitation here is it can balance the load within the same region. If you want across regions, that is when you look at DNS level load balancing, that is Route 53, which we will see later. But today we are going to see how to load balance within the same region using elastic load balancer. And Amazon has recently introduced another type of load balancer, which is called as application load balancer. And the existing one, that is the old one, is called as a classic load balancer. So that's an interesting difference, which we will see when we are going to deep dive in a short while. So as I was saying, the load balancing forms a part of the networking group of services provided by Amazon. We have seen VPCs, we have seen Direct Connect. So let us spend our next few minutes on ELB itself. So why I need an ELB? Without an ELB or without a load balancer, what happens? That is what we are going to see now. So when you don't have a load balancer, it is a very simple architecture. As you can see here, you have an EC2 instance, and if your user is going to access your EC2 instance, the user is going to type something like www.mywebsites.com, and the request is going directly to the EC2 instance. So it is a straightforward, simple transaction. One user, one instance, it's fine. But what happens if you have a multiple users? And that multiple users, when you're talking about, is millions, and all those users are trying to access a single instance of a EC2 instance, a single EC2 resource. So the resource will be overwhelmed and you will have a CPU spike, memory spike, and ultimately the server will have to be rebooted because it is in a hung state. It's not able to respond to any queries. And Unix quite often it will say that it is there is a stack overflow or not able to fork a new process. So what if you have multiple instances, then how do you judicially route your traffic between multiple instances? Instead of one EC2, let us say that you have three EC2 instances, all doing the same functionality. Now, how do I send the user 1 to the first instance and user 2 to the second instance and user 3 to the third instance and keep on rotating it? How do I do that? So this is where a load balancer comes into picture, which has this intelligent algorithm built into it so that it can distribute the traffic between the multiple instances, and it can also scale up on itself. That is on the elastic load balancer that is provided by Amazon. So if you have a load balancer there, and if the user queries are coming at thousands of queries per second, and tomorrow you are getting at 1 million queries per second, that is, you have grown about 100 times or 1,000 times, the load balancer will also have the necessary CPU and memory to scale to cater to that kind of a demand. And if think of it, if you're on the background, you have auto scaling configured, your EC2 is also going to grow horizontally. You will have multiple instances keep on adding. And when your demand comes down, auto scaling will keep on removing those instances. So in this case, auto scaling will inform ELB, and ELB will know that, okay, I have got a new instance, I need to share traffic, or sometimes there is a new instance is having some problem, I will stop sending traffic. So this is how a load balancer will know that where to route the particular request and make sure that the failure is not shown to the end user itself. If there is a server which is having more CPU, it will automatically reroute it. We will see a little bit more in detail in an animated workflow of the data traffic, so that we will see how the load balancing happens. So basically you want to remember that it is elastic. That means that it can scale up and down as and when your request goes up. Just like your auto scaling, the ELB also grows big in scale also. And it is secure. That is because it can support your SSL traffic, and it can drop SSL for you. In other words, you can drop your SSL decryption at your load balancer itself instead of doing it at your application level. If you want to do the decryption of your SSL at application, that is also possible, so that encrypted traffic will be sent to your application servers. So you have security built into it to support SSL load balancing. And as I said, it is integrated. That is what it means. It is integrated to CloudWatch metrics so that you can measure the performance of the underlying instance. It is integrated with EC2. It is integrated with auto scaling. So a lot of other services also, like Route 53 is also integrated. So you don't have to do anything out of the box. It comes pre-integrated with a lot of other services that are running in AWS. It is comparatively cost effective when you compare to other load balancers like F5 or Palo Alto systems that is available in the market. So there is a cost associated with running load balancers per hour cost. When you try to run it in a F5 load balancer and compare it, you will not find much difference. But given the functionality that you are not going to manage the load balancer, you are not going to configure the security, you are not going to protect it against DDoS attacks. So all these management tasks are taken away from you, and if you try to think of any other you managing the load balancer, then all those tasks come on to you, and the cost for that as a whole will become an effective package for you. So this is how a load balancer architecture we are going to build now. Let us say there is a VPC, and inside that VPC there are two availability zones, US West 1A and 1B, and each of those availability zones are having two servers doing the same functionality. Let us say there is a web server now, and they're doing a web traffic website they are serving. And what happens is then what you do is you create an VPC or another subnet for your ELB itself. Either you can do it at a separate VPC level, or you can just create another subnet for your VPC. And once you create an ELB, you have to identify two subnets in each of those availability zones, because remember, it has to distribute the traffic across multiple availability zones. So it is ideal to have two subnets on two availability zones. What sometimes people do is they create two subnets on the same availability zone and try to configure to ELB saying that here are your two subnets, try to distribute the traffic between these two subnets. That is not going to be really highly available, because if one AC goes down, both the subnets underneath is going to go offline. So the best way is create two subnets specifically for your ELB or your web front ends, and then configure your ELB in those front ends. So it is shown as two instances, but it is only one instance of an ELB sitting outside of it, and but it will consume one IP address from that subnet. So it will be connected to those EC2 instances because you are going to attach it. You will when you're creating an EC2 an ELB, it will ask you which are all the instances I want to distribute the traffic. So this is for manual configuration. If you're doing auto scaling, all you have to do is link it to the auto scaling group, and automatically whenever auto scaling removes instances or adds instances, it will attach it and detach it from the ELB itself. So on the extreme left hand side, you have the Route 53 or the DNS service. When somebody types www.mysites.com, the request first comes to Route 53 or a DNS service, which in turn forwards to the ELB. And ELB will in turn forward it to the least utilized EC2 instance, because it keeps a track of which instance is having how many requests, and it will send it to the EC2 instance which is having the most amount of resources available. So this is a summary of some of those things that we just now spoke about. It load balances EC2 instance, and it has support for both private and public IP address. What it means is, let us say you have two instant web servers on your cloud, and one of those web servers are on-premise. So it is possible to distribute the traffic between cloud as well as on-premise resource, which will have an IP address, and you can configure it based on IP address also. And you get full access to your security group for your load balancer. You can, because it is in a subnet and it is inside a VPC, you can create a security group and throw your VPC inside that security group and say that only allow port 80 or 443 traffic through, or deny every other traffic. So this way you will have full control over what your load balancer is allowing into. So we saw that it is integrated with your VPC and subnets. And it is also integrated with your health checks also, meaning it will check your EC2 instance to see what is the resources, what is the CPU, whether it is in good health or it is failed. Remember, when you're doing auto scaling, we saw whether the state is equal to not equal to running, or it is an impaired state. Similarly, ELB also will do some health checks on your EC2 and find out whether it is good for sending traffic or not. So let us take a simple scenario here. Again, three instances, all of them are having a green level of utilization. That means they are having a very low level of utilization, and the user is requesting for traffic. They are shifted to all the three instances without any problem. So suppose, for example, one particular server at the top is having a very high utilization. You can see here the CPU utilization has gone all the way to red. What happens is EC2 will stop sending traffic to that instance. Now it is no longer sending it. And let us say after some time, auto scaling or some admin has come back and started noticing it. You will see that the load on the other two servers are getting increased now because the traffic is being sent there. And some system admin will notice that, okay, something wrong in my instances. One of them is overloading. One of them is on red hot, and other two are getting overloading, and he will try to fix that problem. And once he has fixed the problem, automatically ELB can recognize that, and then it will start sending a traffic. If the system admin is replacing that instance, then he will have to reattach it. But if it is all done by auto scaling, the reattaching will happen dynamically. You don't have to do anything. So once that happens, the load on the other two systems will automatically get reduced, because there is a new instance which is also sharing the traffic now. So that is how your ELB happens in the background. So that's the simplest way you can understand it. And when you're talking about health checks, how does it know? It can do multiple levels of health checks. It can do a TCP/IP ping, or it can do a HTTP and HTTPS. When we are talking about HTTP, what it will do is it will try to request for a page, and it will see what is the return code. If the HTTP request is page 404 or HTTP 200 or 403, it will understand that there is something wrong and try to request or register a failure and stop sending the traffic to that. It can also do a sophisticated checks by doing, you can integrate your API calls to your application, and then send a notification to your load balancer through the API call saying, my particular application on this port is not working, so stop sending traffic. So there are possibilities of integrating deep into your application also. So, idle timeouts. That's an interesting thing. Say, for example, after a certain period of time, your connections are, your end users have dropped off. There are pending connections on the server, but they are not having any transactions. So, ELB will keep on having those connections as active because it doesn't know that your user has logged off or left that system, not logged off. They are not utilizing the connection. So after some point in time, these connections will clog up the server. So ideally what happens is you can ensure a time limit. After that, all the sessions will get disconnected after a certain period of fixed time. If anybody is in India and trying to book an, let us say, a ticketing system with the IRCTC portal, if you're idle for a certain amount of time, you will get disconnected. So it is this is how you achieve something like that. If a user is idle for, say, for example, 3,600 seconds or 1 hour, they get disconnected automatically from the system. So this way you will conserve the resources and make sure the other users are not impacted by people who are just clogging the pipe and utilizing the resources not effectively. So that is what idle timeout means. Listeners, so what are the, you can configure your ELB to listen on different ports. And when I say ports, it can be 80, 443, 1521, any high port which is allowed. And it is also can be configured at a different protocol level also, whether you want to do it at a TCP/IP or you want to do it at HTTP, you want to do it at HTTPS, any of the different protocols are also supported. And each and every load balancer should have at least one listener, obviously, right? If you're configuring a load balancer, that means that you are looking for traffic to be sent to it. So at least one has to be there, and it can have a maximum of up to 10 per load balancer. So you can have multiple load balancers also set up to the same servers. So that is also possible to distribute your traffic. And you can have rules for each and every load balancer also. Say if it is a /login, somebody is trying to access the login page, you can send it to a particular resource. If they are trying to access a particular image or a file, you can send it to a different resource. So you can have different routing rules for each and every listeners that you're configuring. So these rules are going to be based on multiple conditions. It might be based on pattern matching. It might be based on the URL matching, or it might be based on IP address, like on-premise if somebody is trying to connect, or if they're connecting from work from home, like a VPN, then they should be sent it to a particular access. If they're connecting from the internet to kiosk or somewhere else, trying to access it through the internet, then you are sending it to a different login mechanism. So based on business rules, based on simple pattern matching rules, you can create your rules in your load balancer. Quite often this will happen in conjunction or in discussions with your application teams and with also your business users to identify what kind of workflow you want for your load balancer. So rules is not something that everybody sets it up. Only if you want a very sophisticated distribution of your traffic, then you look at it and then configure it. Target groups. So now the traffic has been listened, that is traffic has come in, it is accepted on a particular port and it is accepted on a certain rule. Now where do I send it? So this is where target groups comes into picture, where I need to send my traffic. So my target group can be an EC2 instance, or it can be a container based instance, or it can be any application that is on premise also. Remember, we can do an IP address based targeting also. So you can have multiple target groups, and you can have those target groups set either in the cloud as well as an on-premise, and you can also have multiple ports also registered for the same target group. Say for example, some browser is supporting only 80 and some resources are to be supported by 443. So on the same server, you will be serving both the traffics and listening for both the ports also. So that is what it means by using multiple ports for the same target groups. So there are some high-level bullet points to remember when you are talking about ELB. I'll show it in a nice flow chart of what is the target group, what is the rule, and what is the ports and listeners in a short while. Before that, let us just highlight some of the points that we need to remember. When you are configuring ELB, what you are ultimately trying to do is you are trying to distribute your load and also at the same time increase your availability, because you are having multiple availability zones and one availability zone is gone offline. You don't want your end customer to know that, because the IP address of the system has changed. You just give them the load balancer IP or the domain name, and whatever instances on the background, whether it is AC1 or AC2, they don't have to worry about it, because the load balancer is what they will see all the time, and the background instances can go offline anytime without any impact. So when you're using high availability, use multiple subnets spread across multiple availability zones. And this is what I spoke about just now. I always associate two or more subnets in different zones with the load balancer. That is for your resiliency also, so that if something goes wrong, you will have traffic distributed. So this is as a flow chart of seeing the same data. Now let us say your availability zone in B has gone offline. So immediately what your load balancer health checks will identify this in a short while. Probably it will take a minute or two. And what it will do is that this black color line, the arrow will disappear in a short while. What it does is this instance is taken offline, and your load balancer will know that this instance is not available. So start sending all the traffic to this instance itself, which is on the other availability zone, and every traffic that has been coming here will be sent to that one. So once the other server comes back online, you will return it back. This is also another configuration quite often people will do. What it means is on one availability zone, they will have a very big instance. Let us say about 16 cores of 64 GB of RAM. Under another availability zone, they will configure multiple instances, smaller instances, 1 GB, 4 GB, 1 CPU, 4 GB RAM. So this way, what happens is there is an imbalance on the capacity. So there's a possibility that one instance gets overloaded, whereas the other instances are not getting overloaded, as you can see here. So it is quite possible that imbalanced instance capacity will have a differential feedback to load balancers, and your customer might feel an impact of it. So what you do is there is a concept called cross-zone load balancing, and what it means is traffic will be sent in a mixed way. So this way, all the traffic are getting distributed to multiple instances instead of just sending one from the same load balancer to the same availability zone. You can have it from either availability zones. So this way, the traffic is distributed, and the utilization of the servers are also coming down, so that they are managed at both of them at almost equal level, if not at the same level. So this way, you can do multiple instances of different sizes and enable cross-zone load balancing and ensure that your cost comes down. Quite often people use this strategy because they think that I don't need two instances, but I'm creating only two instances just for high availability. So let me just use a smaller instance on my second AZ and let auto scaling pick it up if something goes wrong, and bump up my instance capacity when something goes wrong. So, but until that point, you will have imbalance in capacity, and there might be one server doing most of the workload and another server doing less workload. So if you enable this, that problem will also be solved. So cross-zone load balancing, we saw this in many number of words. That is what it describes. The same thing. It absorbs the DNS caching, eliminates the backend instance utilization. What it means is there is a sticky session that is possible, because if the first request comes in, the DNS knows that okay, this request is served by ABC instance and tries to reroute it to the same instance. This way, if you're doing cross-zone load balancing, the DNS caching will be updated with both the servers, and then the traffic is sent to both instances. So you don't see the imbalanced utilization of both the servers. So this is the flow chart I spoke about. From the top down, you need to look at it. You have a load balancer, and you have two listeners in this case. And as I said, there can be multiple listeners either based on protocol level or on a port level. Here it is on the URL level, that is on a protocol level. Let us say there is a HTTP blah blah blah, that is the default, and then somebody is looking for a particular image, that is they're trying to download some image or view a photo of somebody or profile images. So based on that image, the target group is going to change now. And here in this case, you see here there are three different target groups configured, all of them doing different functionality. The middle one is for the imaging. Let us say the extreme left is for login, and the extreme right hand side is for payment. So you can have different groups of servers configured for different functionality, and your load balancer will know that you are requesting for a payment gateway. Now, since you have logged in already, a payment gateway is requested, the traffic will come to the group of servers which are doing payment related stuff. So that is what briefly a load balancer does in AWS. So if we take it one step forward and see in an animated way how an load balancer works very nicely with an auto scaling group, this is how it will look like. Let us say, imagine a simple architecture where we have an auto scaling group, and inside the auto scaling group we have two EC2 instances, and in front of that EC2 instances we have a load balancer distributing traffic between both of them. And we also configured CloudWatch metrics. In other words, it measures your CPU and whether the health of the machine is good. And auto scaling is also measuring the same thing using CloudWatch and having its own checks. And remember, ELB also has its own checks. It also talks to auto scaling. It also talks to CloudWatch. So all of them talk to each other. So let us take a scenario forward, and it is now the ELB is looking for the latency information. The ELB is feeding the latency information to CloudWatch because it talks to the servers, so it knows that how fast the server is responding. So it measures the latency and sends it to CloudWatch. Likewise, the servers are sending the utilization data to CloudWatch. So based on this, you might have configured some rules saying my latency is high or my utilization is high. CloudWatch will send an alarm to auto scaling now, and it will trigger an appropriate auto scaling policy. It might be a scale in event or scale out. When I say scale out, it is going to add more servers. So in this case, let us say there is going to be one more server added. So auto scaling has added one more server, and there are 3 servers in my auto scaling group. So as of now, you can see here ELB does not recognize a new server that has been added. So now auto scaling, what it does is after finishing the initialization of the server, and it does all the health checks, and it finds that the new server has come up and it is good to serve traffic, it will send a notification to ELB. Once the notification is received, ELB will start sending traffic to your 3rd server also. So this is how all these 3 services are integrated nicely, and they play very nicely whenever a system comes offline or when the system is under stress. They will add more resources to meet the demand.